Hello everyone, I am back with another video and I've called it Mixed Bag. I know it sounds corny, but that is the only way I had to represent this thing. Since I'm going to be covering a lot of different topics, but they're small and important, we have intercepts, we have concavity, odd and even functions, and at the end counting zeros. Now, intercepts is something that you might already know or have heard about before. Nonetheless, I want to go over it, some important points that I want you to know before you give the test. Now we know there are two kinds of intercepts. One is the x-intercept and the other is the y-intercept. There are four main points. The first one is that the output is zero. You take an x, put it in your function such that the output should be zero. On the other hand, the input is zero in a y-intercept. We take x as 0 to get some output, let's say A. Okay, that is the main point. In an x-intercept, you put in something to get 0. In a y-intercept, you put 0 to get something. The second point is that x-intercept has the coordinates as x comma 0, whereas the y one has the coordinates 0 comma y of the form 0 comma y. As the name states, x-intercept intersects the x-axis and the y-intercept intersects the y-axis. Now, the fourth point is something that I really want to talk about. It is something that you may not know, and if you know, then well and good. It says that the x-intercept can take many values. For instance, if you have a graph like this, these are the axes. I'll change my color. And if you have a graph like this, if you'll notice closely, you have three x-intercepts, one over here, one over here, and one over here. And remember, that is completely allowed. A polynomial or a graph can intersect the x-axis at more than one point. It does not violate any rule. And even we know that throughout our journey, we've seen quadratic polynomials with two zeros or cubic polynomials with three zeros. They intersect at 3 points. But if we talk about the y-intercept, if I have my axis here, and I'll change my color again, it can only take one value. And the reason is that in a function, in a well-defined function, one input value corresponds to only one output value. And if I want to have two output values, then the function needs to intercept at two places. For instance, if I have this, if I have my graph, something like this, you'll notice that it intercepts the y-axis at 3 points, one over here, one right here, one right here. The corresponding x-coordinate is this one, the one that I colored right now. That is x is 0. And you know that if you put x as 0 into a function, you get only one output. In this case, there are three outputs, which is violating a lot of stuff. So a y-intercept can only take one value. Once you cross the y-axis, you're never coming back, you just move ahead. That is something I want you to take care of. I think that's it. Let's move ahead. Now, under function classification, we have two functions. One is the odd function and the other is the even function. And the AP test will ask you at least one question on either of odd or even functions, so stay prepared. What the odd function says is that when you negate the input, the entire output is negated, which means when you have f of negative x, it is negative of f of x. And in an even function, although you negate the input, it is the same as what you would get with a positive input. So f of negative x remains the same as f of x, and in an odd function, f of negative x turns to negative f of x. An odd function is symmetric to the origin, and an even function is symmetric to the y-axis. Now, most of you would understand what symmetric to the y-axis means. If I have a graph like this, I'll take another color. If I have a graph like this, Not exactly perfect, but get it. And if you flip the thing around the y-axis, it will superimpose the other part. If you flip this around here, it's gonna exactly superimpose it again. That is what is meant by symmetry to the y-axis. Symmetry to the origin means that you flip around the x-axis and then you flip around the y. Or the order does not matter, so either the y first then the x or the x first then the y. If I have my axes like this, and I take something like this. This is symmetry to the origin. You flip around the x to get something like this, and then you flip around the y to get the same thing. Or you flip around the y to get this, and then you flip around the x to get this. In both ways, they superimpose each other about the origin. That is what is meant by symmetry to the origin. Now, an example here is fx is equal to x cubed minus x. I'll show you how it actually works. I'll have to get rid of this first. Yes. When I say f of x is x cubed minus x, and then I say f of negative x, according to definition, should be negative f of x. I'll start by putting in negative x. You have negative x to the power 3, a negative sign here, negative of minus x, which is negative x cubed will remain negative x cubed, and the plus minus minus becomes a plus. We have plus x. You take out the negative from it, you have negative of x cubed minus x, which is, in fact, x cubed minus x originally was f of x. You have the negative sign in front and the fx. So this shows that f of negative x is the same as negative of f of x. And the example of the even function is rather straightforward. Fx is equal to x squared. If you put in, let's say, 2, you get 4. If I put in negative 2, I still get 4, right? This is negative f of x, and this is f of x. Both of them correspond to the same output. That is what is meant by an even function. I hope that was clear. Counting zeros, this is another important topic that you must know. In fact, the topics that I teach you here are something that will definitely come on the test. If they don't, then sue me. Okay, let's move ahead. It says that a polynomial of degree n has at most n zeros. If a graph of a polynomial crosses the x-axis at k, 0, k is just any real number, then k occurs as a 0 an odd number of times. And if a graph of a polynomial is tangent to the x-axis at k, 0, then k occurs as a 0 an even number of times. What the first point says is that if you have a graph here, and your graph, let's say, crosses the x-axis over here, this is a point k, 0, then the 0k will occur an odd number of times. For instance, we have a polynomial f of x is equal to k minus x to the power 3. Over here, k will occur as 0 an odd number of times. But if I had the opposite case, if I had that the polynomial has a tangent, I'll draw the graph again. And what the second point says is that if it is tangent, for instance, if I had something like this, it is tangent at the point k, 0, then k occurs as a 0 an even number of times. In this case, a possible polynomial would be k minus x to the power 2, because over here k occurs as a 0 number of times. This is not exactly how a polynomial would look like, a polynomial would have this as a part of something, or this is a probable polynomial for both of these cases. The question here says that find a polynomial function that would match the graph of the polynomial that is given right here. Now, what I want you to understand is that there are infinite answers to this. There are infinite correct answers to this one because no one can actually define something without getting the entire view of the graph. What we'll do here is we'll examine the zeros. We have 1 0 here, 1 0 here, and 1 0 here. Let's start with the first one. We have a 0 at x is equal to minus 2. A possible factor would be x plus 2. Now, the thing I want you to make sure is the power. Okay, we learned that if it crosses the x-axis, then it occurs as a 0 an odd number of times. So we could have x plus 2 to the power 1 to the power 3 to the power 5. But we want to keep it down, we want to keep it simple. So I'll take it to the power 1. That'll just be x plus 2. The second 0 that we have here is x is equal to 0. A possible factor in this case would just be x. And look at it. It crosses the x-axis again. So we either have x to the power 1, x to the power 3, or x to the power 5. And again, x to the power 3 is not incorrect. But since we want to simplify it, we'll keep it x. The third 0 that we have here is x is equal to 5. The point here is 5. 4, 6, 4, 5, 6. A possible factor would be x minus 5. And if you look carefully, it does not cross it, rather it is tangent. It comes back. In this case, it will have an even number of zeros. So we either have x minus 5 to the power 2, to the power 4, to the power 6. And the best choice here would be x minus 5 to the power 2. So the final polynomial that we get would be f of x is equal to x times x plus 2 into x minus 5 to the power 2. That would be your answer. Okay, the last topic we're going to be covering today will be concavity. And while it is not the most important topic, you at least should know what a convex graph is and what a concave graph is. They may not ask you this on the test, but you should know this. Well, I tried looking for a formal definition of a convex and concave graph that is simple and easy to understand. I could not find any of them. The best thing I could find was this. So I'll try my best to explain it to you. Now, in a convex graph, if you take any two points and if you connect them with a line segment, then if the entire portion lies below the line segment, you call it a convex graph. I repeat, in any graph, if you take 2 points, x and y, and if you connect them with a line segment, and if the entire portion lies below the line segment, you call it a convex graph. The exact opposite is the concave graph, where if you join 2 points using a line segment, and if the entire part lies above it, then you have a concave graph. While it may seem quite clear and straightforward in individual pieces, where I show you an individual convex graph and an individual concave graph, you must know this because if you have a mixed graph, say if I have this, and then if I show you a graph like this, you'll realize that this is a mixture of a convex graph and a concave graph. And if I take any 2 points, let's say I take this one, the entire portion lies above the line segment and it is a concave one. If I join these 2 points, it is still a concave one. But what if I join these 2 points? Okay, what if I join these 2 points? Half of it is above the segment and half of it is below. In this case, you clearly state that the first portion is a concave one and the second is a convex one. So that is a way with which you can differentiate between a convex graph and a concave graph. And you should know this irrespective of whether it comes in the test or not. It's a small thing. Yeah, then I think that was the last topic of the day. I'll see you soon. Thank you. Have a good day ahead.